Okay, this second part of transformations, we're talking about dilation. So when we see the word dilated from the x-axis, that actually affects the y value in the image point. When you see the word from so it's always the opposite. So it says from x-axis, so in the image point. So you can see under here, if the original point was xy, the image point is x and a times y. So whatever you're dilating by, the y value gets changed. So in this example, it says write a transformed equation for the function, fx equals the square root, and it's dilated by a factor of 3. And now another way to say in the direction y is another way of saying it affects. So just here I showed you how when you are dilating it this way, you can just look at it that you times the whole function by 3. So that's how we got this. But if we did it with the image point, the way we don't know, so the image x has been changed, it hasn't been changed, it remains the same, but the image y has, the normal y has been dilated by 3, so we'd say 3y. So if we transpose this one, just so we get y by itself, not image y, we can see that it would be image y divided by 3 equals y. So then we could put that into our normal formula. So this was the original, but now because we've changed it, well, y actually equals y over 3, and x is the same. So you look, if you rearrange this now, and you move the 3 over, so you essentially get the same. So we can see we get the same as we do over here. And just this image way is better for what we're going to head into later. And I showed you how you can see in this point in the original graph, square root, if you have x is 1, y is 1. But if we look in the new one, well, y should really be, if x is 1, y should be 3 times what it was before, which it is. So that's just showing you that. Here we've just done another example. So we've got determine the rule for the image when the original graph was y equals 1 over x squared is dilated by a factor of 4. So from the x-axis means there's a dilation on the y value. So we've written that here. So the image y is 4 times the original and the other y is the same. Now we rearranged it to get the y, normal y by itself, so that we could put them into there. And we see that we get y over 4 is 1 over x squared. So we just want to move this so y is by itself, so it becomes like that. If we remember the old rule, we know it's the whole function times 4, the whole function, so we can get to the same. But as I said, this is going to help us doing it this way later on. Okay. The other type of dilation is when we have a dilation from the y-axis. So if we have a dilation from the y-axis or in the direction of x, as it says, it's going to affect the x. So if you look at the image point, we know it'll affect the x. So we see here n times x and y. So we've done both ways to show you. So write down the transformed equation of y equals square root x when a dilation factor of 4 from the y-axis, so that means it affects the x. So here I'm going to do the image way first, so we can see this is how it changed. So I wrote the image is 4 times because that's what they said, and the y is the same. So if we rearrange that, so we get x by itself, so we've got x, it'll be move the x, so x divided by 4. So now we're going to put them into our original equation. So y didn't stayed the same, but x is not x now, it's x over 4. So we do that, and when you write that, this can be written like that. So in the end, we can write the graph like that. Even if you leave it like that, it doesn't really matter. So if you think of it the other way, where we go, if we dilate by a factor of 4, we actually times the x value by 1 over it. So we're timesing here instead of using x, we're 1/4. So we do x over n, and there we end up with the same answer. But let's just start using this as much as possible. And so we'll do another one. So from the y-axis means it affects the x. So let's do it. So the image x will be, because it's a factor of 4, it'll be 4 times the original x. And if I transpose that, it'd be x over 4 is the original, and the y didn't change. So if we write the formula out, y equals 1 over x squared, that's the original. But if I want to use the image, the y didn't stay the same, but the x was x over 4 squared. So when you go to simplify that out, that's actually like saying 1 times 4 over x squared, which is 1 times 16 over x squared. So we get y equals 16 over x squared. Okay, so if you were, so 4 you would times, the inverse of that, which is 1/4, which is here. Alright, but we're just going to leave it like that. Alright, let's do the next one. Determine the rule of the image when the graph of y equals 1 over x is dilated by a factor of half in the direction of x. So it's just another way of saying it, but when we say in direction of x, it means the x got the effect. So the image x is half the normal x, and y remains the same. So if I rearrange that one, 2 times that equals the original. And so therefore, if I wrote the formula out like it was, but now use image y and image, instead of x, I put that it was 2x and squared, you'll see we get 1 over 4x squared. And that is our image or formula. Okay?